Welcome to the DIY Honda Garage channel. The DTCs P2096 and P2097 are crucial diagnostic trouble codes that indicate issues with the fuel trim system regarding post-catalytic converter operations on Honda CRV models from 2017 to 2022. DTC P2096 signifies that the post-catalyst fuel trim is too lean, while P2097 indicates that it is too rich. Essentially, these codes signal that the engine control module, ECM, is not receiving the optimal air-fuel mixture required for efficient combustion after the catalytic converter. The affected components include the air-fuel AF sensor, which measures the concentration of oxygen in the exhaust gases, thereby informing the engine management system to adjust fuel delivery accordingly. The secondary heated oxygen sensor, HO2S, also plays a vital role as it provides additional data for fine-tuning the fuel mixture. These sensors are typically located in the exhaust system. When these codes are stored, it often signifies underlying issues in the vehicle's emissions control system that must be addressed promptly to ensure optimal performance and compliance with emissions regulations. DTC P2096 indicates that the post-catalyst fuel trim is lean, meaning the air-fuel mixture is too oxygen-rich, resulting in insufficient fuel. Conversely, DTC P2097 indicates the fuel trim is rich, suggesting excess fuel in relation to oxygen. The AF sensor is critical as it detects the chemical composition of the exhaust gases, which helps the engine adjust fuel delivery to maintain optimal combustion. It's located in the exhaust pipe, upstream of the catalytic converter, while the secondary HO2S is generally downstream and assists in verifying the AF sensor's readings. Any discrepancies in readouts from these sensors can lead the engine control module, ECM, to miscalculate fuel trim settings, causing performance issues along with increased emissions. Therefore, promptly addressing these DTCs is vital for both vehicle performance and environmental compliance. Several factors can lead to DTCs P2096 and P2097. First, a faulty air-fuel AF sensor can misreport the air-fuel mixture, leading the engine control module, ECM, to make improper fuel adjustments. Second, the secondary heated oxygen sensor, HO2S, could also be defective, which would compromise the accuracy of data necessary for fine-tuning the mixture. Moreover, any leaks or blockages in the exhaust system located between the AF sensor and the secondary HO2S can cause erroneous readings, contributing to an incorrect fuel trim. Lastly, anomalies within the fuel system itself, such as low fuel pressure or faulty fuel injectors, can also affect the mixture and provoke these codes. Recognizing these possible causes is essential for accurate diagnosis and effective repairs. When the DTCs P2096 and P2097 are triggered, several noticeable symptoms may develop. Initially, the check engine light on the dashboard will illuminate, indicating a malfunction in the exhaust system's air-fuel regulation. Drivers may also experience poor engine performance, as the incorrect air-fuel mixture can lead to inefficient combustion, resulting in sluggish acceleration or a lack of power. In addition, higher fuel consumption may occur, as a lean or rich condition often requires more fuel for the same power output. Lastly, rough idle conditions could arise when the engine struggles to maintain a stable RPM due to fluctuations in fuel delivery. Awareness of these symptoms can help in early diagnosis and rectifying the underlying issue before it escalates. The first troubleshooting step requires the technician to turn the vehicle to the on mode without starting the engine. This allows the diagnostic tools to initialize and prepare for proper data monitoring. Next, Clear the existing Diagnostic Trouble Codes, DTCs, using the Honda Diagnostic System, HDS, ensuring that any temporary faults are removed before proceeding. After clearing the DTCs, start the engine and hold the engine speed at 3,000 revolutions per minute, RPM, without any load until the radiator fan activates, indicating that the engine has reached an adequate temperature for testing. Once the fan comes on, allow the engine to idle. This step is crucial as it sets up the conditions required for the system to accurately evaluate the vehicle's sensor readings and systemic performance before initiating further diagnostics. After clearing the initial DTCs and monitoring the engine's operation, the next step mandates checking the conditions under which the vehicle operates. Specifically, ensure that the air conditioning, AC, is turned off and all electrical loads are minimized to facilitate accurate testing conditions. Utilize the Honda Diagnostic System, HDS, to conduct the cylinder air-fuel AF variation test 3 times. This test isolates any potential issues related to air-fuel mixture variations across the different cylinders. After performing the test, analyze the results. If the output is satisfactory, yes, proceed to the next troubleshooting step. If the result indicates an issue, no. This points towards a potential fault with the AF ratio in a specific cylinder, necessitating further investigation under DTC P2096 for cylinder misfires or mixture variation. In this troubleshooting stage, first turn the vehicle to the off mode to ensure safety. Following this, a thorough inspection of the exhaust system is necessary. Look for any leaks, clogging, or blockages that may disrupt the normal flow of exhaust gases. It's critical to check areas between the air-fuel A-fuel sensor and the secondary heated oxygen sensor, HO2S, since any discrepancies in exhaust flow can lead to skewed sensor readings. If any leakage is found in this section of the exhaust or evidence of clogging is present, repair or replace the faulty section immediately. Exhaust leaks can drastically alter the air-fuel ratio and directly contribute to triggering DTCs, P2096 and P2097, requiring prompt attention to ensure vehicle performance and compliance. Upon confirming that the exhaust system is free of leaks and blockages, the following step involves verifying the functionality of the air-fuel AF sensor. Substitute the suspect AF sensor with a known good component to eliminate the possibility of sensor malfunction. Once you have reconnected all connectors, turn the vehicle to the on mode once again. After this, reset the powertrain control module, PCM, using the Honda Diagnostic System, HDS. This step is essential as it clears stored data and allows the PCM to relearn optimal fuel trim values. Following the reset, perform the PCM idle learn procedure, allowing the unit to adapt to the new sensor settings. This is vital as it guarantees that the vehicle's computer can effectively manage the engine's air-fuel mixture, leading to accurate diagnostics. After substituting the AF sensor and performing the necessary resets, the next task involves monitoring the onboard diagnostics OBD status with the Honda Diagnostic System, HDS. Analyze the results carefully to determine if the HDS indicates passed for either DTC P2096 or P2097. If these codes show a pass status, it confirms that the issue was with the original AF sensor, and you should replace it with the new part. This replacement should resolve the underlying lean or rich condition affecting the fuel trim. However, if the HDS shows a failed status, it is essential to investigate the secondary heated oxygen sensor, HO2S, instead. If the system indicates executing, maintain the testing conditions until you receive a definitive outcome. And if it shows out of condition, return to the previous steps and recheck the conditions. The final step in confirming the repairs involves running a series of verification tests to ensure everything operates smoothly. Start by checking the engine at idle and observe for any anomalies in performance, particularly focusing on engine vibrations and idle stability. Make sure that both DTCs P2096 and P2097 do not return during this observation period. Next, confirm that all systems, including the emission system, are functioning correctly without fault codes appearing. After this, conduct a final test drive under normal driving conditions, ideally replicating the previous scenarios where DTCs emerged. Monitor the vehicle closely for any check engine light activation or performance issues. If no codes are triggered and the vehicle performs as expected, repair verification can be deemed successful. Preventive maintenance is crucial in preventing issues like DTC's P2096 and P2097 from arising in the first place. Regular inspections of the air-fuel AF sensor and the secondary heated oxygen sensor, HO2S, can help detect early signs of wear or malfunction. Likewise, always check the exhaust system for any leaks, clogging, or restrictions. Regularly maintaining the fuel system, including the fuel injectors and pressure, will also ensure an optimal air-fuel mixture and contribute to improved engine performance. Consider scheduling periodic inspections and employing diagnostic tools to catch potential issues before they escalate into trouble codes. Proactive maintenance will not only enhance vehicle efficiency, but also prolong the lifespan of critical engine components. In conclusion, DTC's P2096 and P2097 serve as important indicators of fuel trim issues that can significantly affect the performance and emissions of Honda CRVs from 2017 to 2022. It is essential to understand the roles of the AF sensor and secondary HO2S in managing the air-fuel mixture effectively. Troubleshooting involves a systematic approach of verifying DTCs, inspecting exhaust systems, and ensuring sensor functionality. Furthermore, regular preventive maintenance should be incorporated to mitigate risks of these DTCs in the future. Addressing these concerns not only optimizes vehicle performance, but also aligns with environmental compliance, making it crucial for both vehicle longevity and sustainable use. Please like and subscribe to the channel. See you next time.